I'm gonna tell you a story. About a year ago, when I was building my hexapod robot, I started to be real interested in leg robotics, especially bipedal robots. So I saw for the first time robots like Atlas from Boston Dynamics, and this is the coolest robot ever. It dances, it does dynamic stuff, and it's just really cool. So I looked at some simpler robots that I would be able to build in my lifetime, in theory. I found Cassie, which is just a robot with 2 legs and nothing else. It's the simplest bipedal you can make, well, almost. I started reading some work on this robot. It wasn't that bad, I understood generally what's going on, and I set myself a goal that in my lifetime I would build a bipedal robot that would be dynamic. I think that the hardest part about these robots is the controller. For bipedal robots, you can't just hardcode the movements like I did for my hexapod. You can't use PID or LQR, this wouldn't work. You either need some MPC or optimal control, or a polysig controller with a neural network, which seems like the easiest option, because you can just simulate this robot in a program and it will learn the controller. So you don't need to write down equations or understand it. You just slap a neural network on it, let it learn, and it should be fine. So that's the option I went with, and I started to look into some programs which I could use to simulate these robots. The first thing I did is I found a bunch of Python tutorials. So for example, this one, it's a very simple 2D case, and you basically let it learn to walk. This would be completely useless in real life, but it would be a good starting point. So I watched some of these tutorials, I tried to run them, and it never worked. There was always problems with compatibility. Even when I installed the specific versions of each of the packages, it didn't work. I've tried this like 5 times. I even tried this metal robot, which is supposed to learn to walk too, and it's in 3D. This was outdated too, so this was really discouraging. I couldn't even run pre-made scripts. So I said fuck it, I'm not gonna waste years of my life banging my head against the wall, and I stopped trying. But then, about a week ago, we had a class and the teachers showed us some of these programs, like this code from Stable Baselines 3. I actually got it to run. He showed us how to install it and it worked. It still didn't move me quite as much because you can't transfer this to the real robot. But then he showed us this robot, which is super cool. And I'm not sure, but I think this was trained in something like Isaac Lab, which he showed us too. This promises high fidelity, which means it has realistic physics, and you can actually transfer this to real robots. It's from NVIDIA and it's free. This kind of motivated me, but I still wasn't set on it. I don't like Python, and coding these things is just quite painful, so I wasn't even gonna try it. But from that point on, it was all the time in the back of my mind. I could potentially simulate a bipedal robot and sometimes in the future maybe even implement it. One day I just got to my PC, started installing it, and this is where I'm at right now. I spent 3 days with this program and I'm gonna show you my progress. So you might be wondering how the robot is able to learn such complex tasks. Take this with a grain of salt. This is just generally what I think is going on. So this is a neural network. It's the brain of the robot. And what it does is you input the command, for example, walk forward, and also some sensor data. In order to be able to walk, the robot needs to know where his legs are, if it's tilted and things like that. So you input these 2 things and it calculates the motor angles. This sounds great, but the question is, how do you get this neural network? Well, creating it is actually quite easy, because it's just a bunch of equations, but the problem is having it set correctly. The neural network is defined by weights and biases, which are just a bunch of numbers. And if we find these numbers, the neural network is gonna behave how we want. We do that by first setting these numbers randomly. It calculates some random motor angles, and we simulate what the robot does. Based on the simulation, we need to tell the neural network how well the robot did. We do this by introducing a reward function. We can add a score to the robot based on how well it's doing. For example, if the robot falls over, we take off points, and for each second the robot stays upright, we give it some points. This way the robot would probably learn to just stand still, but we want it to walk, so we can also add some points for when it's following the command. For example, when you tell it to move forward with some velocity, if the robot follows this velocity, we give it reward too, and that way it should learn to walk. Based on this reward, the policy is gonna update the weights and biases, and doing this simulation many times over, it should learn the correct behavior and follow the commands. After training the robot in simulation, we take the neural network and surgically install it into our robot, and it should work in real life too, if the simulation was realistic, that is. On day 1, my goal was to install Isaac Lab. That's all I wanted to do, because it's quite hard. So Isaac Lab runs on Python, so you need to have Python installed, and for me, to make the coding simpler, I use PyCharm. You can also use Visual Code Studio. So I just googled Isaac Lab and I found this GitHub page where there's a tutorial for the installation. It's not that straightforward to install it, so you even need a tutorial for that. Isaac Lab installation, then pip installation. With pip you install all the Python things, and here's the tutorial. So I just followed this. So I'm using virtual environment Windows, and they want you to use Python 3.10 point something. You need to create a virtual environment with that. So I just clicked new project, I named it Isaac Lab Test, and for the virtual environment I used Python 3.10 something. I created the project, and then inside it I was able to open the terminal and start installing the packages. So I just followed this tutorial. You can just copy it, open the terminal, run this script, and it will install PyTorch, CUDA and everything you need. Some of it took quite some time. I think PyTorch, yeah, I had to install that 3 times. That took like 40 minutes. So I just went through this, installed everything, and up to this point it was okay, because this was just the Isaac Sim installation. And Isaac Lab is kind of an improved version of that, so that's where I started having problems. This didn't work. I have no idea what SSH is, but I used this one, which worked. Then it was installed. I had to reinstall PyTorch 2 times because there were some compatibility problems, and I used ChatGPT for that. It gave me like the compatible versions. After I was done installing the Isaac Lab, I just verified that it works with this, I think. When you run these scripts, you need to be in the correct directory. Right now I'm in this PyCharm projects directory. In that I've installed the Isaac Lab. To actually use this command, you need to be in the Isaac Lab directory. So I'm just gonna open a text file here, and to get to the Isaac Lab directory, you just type cd, and then you copy the directory path. So my directory is this, PyCharm projects, then Isaac Lab test, and Isaac Lab. So I copy this, put cd, then the directory, and if you paste this into the terminal, you can see that now I'm in the Isaac Lab directory. After that I can use this command, but before it you also need to put like backslash and dot. Fuck. Okay, it's first dot and then backslash. Yeah, now it's starting to open up. So it's gonna open the Isaac Sim, and it's gonna open an empty environment. Yeah, it's open. So after this, you can start training robots. I'm gonna train a robotic dog to walk. So I just copied this test command, and again, you need to use dot and backslash. Maybe there's a better way to do this, but this is just how I've done it. I don't like Python, to be honest, so I don't know much about it. Let's see what it does. Oh yeah, I forgot, this command has headless at the end. By these commands you can set what type of training you want. So if it's headless, you're not gonna see the robot dogs. This way is just training the robot dogs without rendering them, which is good because it's faster to compute. I wanna see a bunch of robot dogs. It's Ctrl+C, capital Y, and this ends the simulation. I'm gonna type the same command but without the headless thing. And also, since we have already touched that, You can also type other stuff, like number of environments. So here there's gonna be only 8 environments, which means 8 robotic dogs. Before it was set to the default value, which is pretty high, I'm sure. So this is gonna be easier to render. And the robotic dogs have been loaded. I think it's the green arrow, that's the command. So we want the robotic dog to walk along the green vector. And the blue vector is the actual velocity of the robot. And it's at the start of the training, so right now it's really bad, and over time it should improve. When I first got here, I was surprised that the camera is so bad. You can like zoom in, but it's not great. So what you can actually do is, instead of follow mode world, you can go for the robot, and then based on this environment index you choose which robot to follow. So you can pick your robot, and then with this you can move the camera. So if you just click on this, left click and hold, and go left or right, you can sweep through the coordinates. So I'm gonna put it really close to the robot. Z coordinate. Fuck. Yeah, now we can really see the robotic dog. Very nice. It's also nice to see the environments they have. They are training robot dogs on different terrains, so they will be more universal. If you just trained it on a flat ground, it wouldn't be much useful when you want to walk upstairs. Simulating these robots is a lot of fun, but if you want to build one in real life, you're gonna need some PCBs. So this is my sponsor PCBWay. They do a lot of manufacturing, like CNC machining, injection molding and 3D printing, but I mainly use them for the PCBs. I've used them for my hexapod robot, for the robotic arm, and I'm gonna use them for my robotic dog project. If you buy PCBs that are under 100 by 100 millimeters, you can get 10 of them for $5. And if it's your first time using PCBWay, you can click the link in the description and you will get a $5 discount. So this was the first day. The things with the directory, like using this dot and backslash, I didn't know that before I started this. So I've got a bunch of errors and it took me some time before I figured it out. Overall, it wasn't that bad. To get to this point with the installation and everything, I think it took 5 or 6 hours. If I knew what I was doing, it would be probably 2. What I also liked about my first day with this program is that I recognize this robotic dog. I've seen it on YouTube, I don't remember the name, but it's really cool to see these real world robots in this simulation. They also have the Spot robot, I think, from Boston Dynamics, and the Cassie. I was surprised by that. So this was my first day and I was hooked, to be honest. At day 2 I wanted to import some models from the community. So I searched some tutorials on YouTube and found this gem. So this guy is called Robot Mania, what a name. It's a great tutorial, really watch this video. He installs the Isaac Lab, then defines the problem. So you have this robotic dog with wheels and you want to balance it on the back wheels. I skipped this step because I didn't know how to open the Isaac sim without running a script. Well, now I know that, but before I didn't, so I just skipped that. He goes through the script, explains what they do. After I downloaded the files, I just imported the project into Isaac Lab, source, Isaac Lab tasks, manager based, classic, and here I've put in the folder. And these scripts were already outdated, even though the video is like, holy shit, 2 months old. Yeah, so in these scripts, they were made with like old version of Isaac Lab. So I got an error which didn't recognize this term, and all I had to do is switch this for Isaac Lab, and after that it worked. So I just pressed Ctrl F. I've put the term that doesn't work and I switched it for this term and I pressed replace all. Also, one other thing I needed to change was the path. Just found where I had the USD file, which I think is the physical model of the robot, but I'm not sure. I've just followed the tutorial. I copied the path. You can do it if you press Ctrl Shift and C, it will copy the path. So I've changed this. After that, it worked with no problems. These are the commands I used for training. I just ran the script. It's stable baseline 3 instead of RSL like before. You just ran the train.py script. So this is a generic training file. Then you import the task, so this is your robot, and then you can put number of environments. Headless, so I wanted to actually train it, so I didn't render it. And if you type video, you will get every 200 steps or something, it will take a short video, which you can then see in the logs and follow the training. So again, I typed it in the Isaac Lab directory. We just pasted the script and it started to learn. This is what it looks like when you're running the training phase. You get the iteration number, the time steps, and this is the reward function. This number, the 79.9, that's how much reward the robot is getting. The value doesn't matter itself, it just matters that it should increase over time. There's also a bunch of other parameters which I'm not gonna get into because I don't know what half of them mean. But I can recognize some of these from, like if you train neural networks, it's similar. It took, I think, 1 hour, and after that, if you want to see the training videos, you go to Isaac Lab, logs, and based on which method you're using, so this was stable baselines 3, your project, and then you can see the dates. You go to the newest date, videos, train, and you go to training videos. I've trained this robotic dog a bunch of times because I wasn't quite happy with the results. So this is where it ended up. It's obviously shitty, but it's better than the start. It's using its front limbs, but it still falls over. Yeah, this is not revolutionary. I used the basic configuration the Robot Mania guy had, and it didn't turn out great, and I think he said in the comments that he had to run it a few times before he got decent results. Yeah, his one was working great. So mine didn't quite work. I looked into the code a bit and started changing some of the parameters. So in the environment file, there's the reward function defined. Yeah, this one. So the robot gets some reward based on how long he stays alive. That's until he falls over. This is the weight of the reward. Then he gets punished when he falls over. He loses 2 points. He gets reward when he's upright, so he's not too tilted. So I played with these weights and didn't get better results. I still don't know how I can add different types of rewards. I just changed the weights. So that's what I'm gonna look into next. There's also this PPO file, which is for the learning, and you can change some parameters here too. So this is the neural network. That's the policy that's controlling the robot, I think. I haven't looked into it, but I'm pretty sure with these two numbers you defined the number of hidden layers and how tall they are. One hidden layer with 32 neurons and a second one with also 32 neurons. I've tried to increase it, decrease it. I've played with that. Then there should be, yeah, a learning rate. I tried to increase this. That's also a term from coding neural networks, but I haven't got any better results, to be honest. Then after it was trained, I used this command to play the latest checkpoints. So that's the latest trained model, and with that you can visualize the learned policy. This is the model I just trained, but I stopped it super quickly. I just did it for the video, so it's not trained well. But you can even type specific model you wanna play. This one has a lot of videos, so this should be trained well. So I'm gonna get like the second to last model, copy as path, paste it into that, and I think this should work. For some reason at the start of the training, it got the idea that like putting one limb behind its back and one in the front, it's good. So it got stuck at this local minima, and I think if I let it train for a longer time, it would find a better solution, but this is where it got stuck. At day 3, I wanted to import the Cassie robot and try to train that to walk. As it so happens, it's already in the Isaac Lab folder. So if you go to Isaac Lab, source, Isaac Lab tasks, Isaac Lab tasks again, manager based, locomotion, velocity, config, and here's the Cassie robot. So you can choose flat, ground or rough terrain. I chose the rough terrain. I don't remember if I had to change anything here, but I played these scripts. So for training I played this one and I let it train for some time, but for some reason, even though I put video here, the videos it took were very weird. It learned to walk. You can see that it tracks the velocity vectors pretty well. And it's really cool to see that the robot learned to walk just by doing many simulations. But the video is quite trash, so I wanted to play it, and this is where I ran into some problems. For some reason, if I try running the play script, it creates the environment, it opens Isaac Sim, but then it just crashes and I get some weird error. I've tried a few things. ChatGPT, not really helpful with this stuff, to be honest. Forums, there was nothing. It's probably just some stupid mistake I've made and it crashed. So this is the error. Self.actor is equal to this. Function object has no attribute actor. So if you know how to fix this error, definitely let me know. And by the way, this is the Cassie work, so I'm gonna link this in the description. It's amazing. This will give you like a high level general overview of how the Cassie robot works and how the policy, the neural network, was trained. Also the tutorials from the Robot Mania guy. For a class I'm taking, I'm probably gonna have to make some project like a humanoid that learns to walk. So I'm gonna upload that should be interesting. And for now I'm gonna focus on my other projects and I'll probably get back to this once I have my robot dog built. So that's where I'm at with Isaac Lab. If you have any suggestions, definitely type them in the comments and I'm gonna see you next time.